All right, let's switch to English, maybe.
Yep. So our first speaker is Majid. And today...
Hi, Majid.
Hello.
Hi, Majid.
How are you doing?
I'm doing very well. Can you hear me, by the way, very well?
Yeah, we can hear perfectly.
What about you?
Good.
Great.
Yes, perfect. Clear.
All right. So our first talk will be about JavaScript threads. So how to make our apps less laggy, and I think we can give. We can switch to Majid. You can start.
Perfect. So, thank you, guys, and I'll start. I'll switch to my slides. By the way, I hear a little bit of echo, so I'm not sure if it's mine or. Oh, seems it's okay now. Good. So, just signal if the slides are okay and you see it perfect, so then I can start. All right. So, hello, good morning. I hope that you started a very good day by now. And the first, it's going to be a bit of a challenge and practical and theory all together. So we're going to go through like some tips and tricks to see how we can improve our app with leveraging different thread in the browsers. So the title of the talk, as you see, it's let the main thread breathe. So sometimes when we actually build our application, we try to somehow like put a lot of things into main thread. So today we're gonna just talk about this and see how we can give some space and room to main thread and let it breathe, you know, smoothly. So let me just tell you the story. So how this idea came to my mind and how I implemented in my application. It was some time ago, maybe a few years ago, I was searching a statistic and check for the number of users who are connected and who are online, and I realized like maybe around 2 years ago it was about 50% of the population around the world. And a few months ago I tried to find out a new statistic, and I realized that actually around 9 to 10% more of the population compared to 2 years ago are online. So, and surprisingly, many of these users, around 90% of these users, are connected to mobile devices. Thinking like when we are talking about mobile devices, we're talking about not just iPhone or very high quality Android phones. We are also talking about maybe some good phones, but lower spec, lower CPU, RAM, and hardware. And many of these let's say people are actually connecting to internet via these devices. And it's very interesting to see that, especially in emerging markets like maybe India, for instance, or some countries in Europe, let's say, or maybe in America, some cities. So people are also using or connecting to internet via these devices. And of course, like we have high performance phones and very expensive one, and at the same time we have the phones like Nokia 2 or 2.1, which is a quite reasonable phone, and it's quite cheap, and you have the latest maybe Android, good quality Android phone, everything is fine, and many people are connecting via these phones. But when we are actually developing our application, how does it look on these phones? Does it run smoothly as it runs on iPhone? Or so, yeah, we should test, right? We should check. What we don't want to see on an iPhone or on other phones or in desktop is this screen. we don't want to give our user like unresponsive page error, or we don't want to make them frustrated because, you know, they cannot click on something, they cannot touch because something is happening and the main thread is blocked and they cannot do anything, right? So we just want to relieve these frustration. So, but the question is that how many ways like existed right now so we can actually use in the browser and try to make this main thread less busy, right? The most important thing that we need to take into account is that at the end, we need to care about all of our customers, all of our clients. As especially a web developer, we need to test and test and test and make sure that our application, especially web application, works as smoothly as it should be on most of our users' devices. And in fact, if you are testing on lower, spec devices, we can somehow guarantee that the higher end, spec devices can see better, application or performance. So in talk, we're gonna actually explore some theory and about like a main thread and why we are saying that it's busy, what the main thread is doing these days, and then we just move into some old ideas of web workers. We know all of that. It's around since 2012 maybe, or 7 something. And then we go to some new ideas like WebAssembly or Worklets. Like how can we use these ideas and try to offload something from main thread to the workers thread or these off threads? So let me introduce myself. My name is Majid Hajian. I'm based in Oslo. At the moment, I'm not in Oslo. I'm in some villa somewhere out of the city, but I'm very happy to be at your service. So I'm a software developer, and I'm also a passionate organizer of several different conferences. I'm also author and instructor for different publishers. You can also find me on the internet, mostly with this handler that you can see on the screen. But enough of me, let's just continue with the main thread. So we, as a web developer and a JavaScript developer, we know that JavaScript is running on main thread, and the idea of having this main thread, it's not something new. Like it's been around since forever, perhaps. And the main thread in JavaScript, as you see here, it does a lot of things. It started to having event, like we know event loop, perhaps. It does JavaScript execution. It does styling, CSS, etc., layouting, painting, composing, and it's a lot of things that is happening in main thread. And so back in the days, maybe 10 years ago or 15 years ago, the application weren't as advanced and complex as today. And today, we are making our application even more complex every day and adding a lot of things to this main thread. It's just one worker, and we just put all the effort on that, worker. So the main thread is gonna be very busy and at some point tired. And once it's tired, well, of course, it will disappoint you because we are expecting this worker to show us 60 FPS perhaps. And that is running smoothly. Animation runs smoothly. Everything is fine. And user is happy, interacting, scrolling very nice, right? But in fact, when we are adding all of these pressure on the main thread, then, well, at some point, it tries like not to show as smooth as it should show. Let's actually do a calculate here. Let's do a math. If we are going to show 60 frames into 1 second, right? So we have around 16 millisecond budget. So in 16 milliseconds, so you need to do a lot of things, right? And if we just have this task, let's say one task for 16 milliseconds, you get like a smooth flow of your app, right? If you run it on higher and good spec of hardware devices, perhaps it's totally fine. It's okay, you see it fine. But if you run it on lower end devices, then you are over budget because, you know, because of the spec, because of hardware and a lot of other things, right? That's the same task. So you see that is the reason we need to optimize our application for lower end hardwares and test it on that. And that's not the only things. Think about screens. You know, CSS, it's okay on 60 hertz, perhaps a screen. But if you have 90 hertz or 120, or maybe in desktop you have more, of course you may have even better hardware. But remember, you are putting a lot of your frames into 1 second, and your body shrink down to maybe 9 seconds, 11 seconds for maybe 19 hertz, or 8 seconds for 220. So you have less and less time to deliver these frames. And if you have a janky frames, that is why then you don't have smooth application. And that is one of the reasons, though, you get unpredictability of your app. So it runs on one device or runs on iPhone X or 12 or whatever, like very high quality device, very smooth. But then it runs on the other one, very, very unpredictable. It doesn't run as smooth. It just have janky frames. So we want to avoid this unpredictability. We as a developer are responsible of reducing these janky frames or handling these unexpected, and then deliver a better user experience to our customers. So, and to do that, then of course we need to hold off task from main thread to other threads, right? So the first thing that I like to bring it up is WebWorkers. WebWorkers are awesome because they are, this is not a new concept. Many of you right now know it, but I bet if I was actually in your conference right now in person, if I ask like how many are using WebWorker in production right now, maybe I actually asked in different conferences, and maybe around 5% say yes we do, but 90%. But who doesn't know that? Everyone knows that. Everyone knows WebWorkers because they have been in the browser since 2012, stable versions. And since then, it's running very smoothly on most of the browsers, right? So they are awesome because when you are actually spawning a web worker, it's similar like you are opening a tab, but somehow it's a headless tab, right? So they don't have some characteristic as main thread, but they can handle business logic very well. So in fact, if you want to actually quickly talk about it, to just refresh our mind, is that when you are actually spawning these workers, you are, you know that these workers, similar to the main thread or the similar tab that you are opening, they have even loop and everything similar to that, right? And the way that we communicate, so you may are familiar with that, the way that we communicate with that is via this post messaging system. It could be in a string, but as well, it could also be like a little bit, you know, maybe old-fashioned to use this technique to communicate via main thread and worker thread. So in fact, it would be very nice if we could get somehow an access to these worker thread directly without any post messaging system. But let me tell you before I continue. One of the reasons, like in let's say in a native apps, iOS or Android, let's say. So usually the main thread in the browser, what we are telling right now, it's called UI thread. And the reason for that is that, so in the UI thread, you have access to UI and you can just manipulate it. It's similar to main thread, you have access to DOM and you can manipulate it. However, when you want to do some kind of business logic task, you can simply just offload it to other thread. And once this done, you can get access to the main thread again with the data and result and do whatever you want. So it's very nice if you can have similar approach in browsers, right? We do have this approach via post messaging from worker thread, for instance, but a little bit easier and similar to native apps, because at the end of the day, we just want to get a web app, like a progressive web app that runs as smooth as those native apps, right? So even the techniques could a little bit be improved. So luckily, we do have the tools these days. You may not have heard about this library, Comlink, but this is an awesome library that I have used it for a few projects so far and so satisfied. So the way that it works is fairly simple. So you still have your worker JavaScript and you still have your main thread. But what it does for you is just you exposing your services or functions or objects, whatever you want from your worker with Comlink. And from the main thread, what you can do, you can just wrap your worker and then it will promisify those post messaging system for you, and you can directly call a function in worker thread, and you get a promise back, and then you can continue doing your code. It's similar to this. You just wrap it, and then you just await for your call your function and await for the result, right? Make it so smooth and easy to work with WebWorker for sure. So, and one example could be, like, let's say in React, for instance, if you are a React developer, you can use it in any JavaScript application, no problem whatsoever. But in React, for instance, so you can simply wrap it as a service and you can call this and set the state without doing this overhead of a post messaging system. So you can simply deal with this awaiting of this promise and then change your state. So there are actually use cases, a lot of use cases for using this pattern, like especially with this library. So think of when you have in your application, again, back to the React, because in React, we have Redux, for instance, as one of the most popular state management, right? And perhaps many of us know how it works, but even if you don't know how it works, you can see it in a slide, and I can tell you quickly. So you have a universal store that you store your state, and reducer just return this state, this unique one, every time you want to change something. And from UI, you need to dispatch some action to tell the reducer what to do and give you this state, right? This is what we do in React or maybe other applications, other JavaScript framework. This is a pattern of Redux, right? But if you think about it, you see that we are doing this. Sometimes our reducer, this is a synchronous task, right? Sometimes it takes time to do something and gives you the state. And that is exactly what we want to avoid, because if this happens, then you're blocking your UI. Your user cannot do anything. They cannot just interact with the application. This is a use case that you can use. You can just hold off this reducer, or maybe even store to the worker thread, just spawning a thread, do the calculation over there, and let your main thread, or let's call it UI thread, just do UI. And that's it. And your user can interact, right? But you may ask, okay, if I want to do that, does it even run fast, or is it faster? Well, the question here is not if it's faster or not. Let's just go through it. So you have this main thread, right? But if you just look at this example of spawning a worker, that means you're adding a little bit overhead, just a little bit overhead for your, a little bit of maybe time for this procedure, right? So that is correct. You are doing that. But in fact, by doing this a little bit over, try and make it more reliable. So the more it's reliable, the user is more happy because they can interact with the application. And you know, sometimes maybe keeping your user waiting a little bit time, worth it, instead of just blocking UI and make them frustrated. So that's probably one thing you can always, when it comes to the usage of WebWorker and spawning this WebWorker, should come to your mind. By doing this, am I making this reliable, although I add a little bit extra time? If the answer is yes, and the UI thread or main thread, let's say, is breathing, you are making it less busier. So why not? You should do that. So, and one more thing that I need to also tell you is about the cores. So in fact, I actually have a full talk about parallelism in JavaScript, but let's quickly go through it. In fact, if you're actually spawning the thread, and if you have several cores in the browsers, in the system, especially on the phone, let's say, so first or second core, usually they can actually run these threads in parallel, but you don't know as a web developer, but it may happen. But if this parallelism happens, that means they can even run faster. But just keep in mind, sometimes if, especially in the phone, more than one core or two cores, you may even have slower time. But the thing is that, the important thing is that it's very hard to measure, but it's something that you as a developer don't have full control over it. But the thing is that, the good thing is that if it happens like a parallelism, then you have a faster even time to deliver something to the user. That is cool. So let's actually see an example here, a demo example. So you see this animation on the screen right now runs very smoothly when I actually do some execution of this state changing in the browser, right? Don't worry about this example. You can find my slides probably after this talk, and you can check out source code and everything yourself. No problem whatsoever. So as you see here, let's run it one more time. When you are actually doing those CPU-intensive, tasks, by spawning the worker thread, getting the response back with comlink, which is very easy, just wait for the response and then changing the UI, still it's interactive and the animation runs smoothly. But if you do the exact same thing in the main thread, then you see it's blocking for a few seconds, maybe a second. And that means even your user cannot touch anything or click on anything. And that makes frustration. So let's move on. Web workers are not the only way that actually can hold off some task to a thread, right? So WebAssembly is also a new concept which is around for a few years, and these days is in the many browsers are like giving us a very stable version of WebAssembly. So we can leverage using this WebAssembly and holding off some of these tasks from main thread to WebAssembly thread, let's say. This is a kind of like a worker thread. So some similar characteristic you can inherit from WebWorker, but with some difference. We're not going to go through the theory of WebAssembly. I bet you've heard and you may even know, but that's not important. When we are talking about WebAssembly, first comes to your mind what it is. Perhaps you're thinking immediately, oh, you're talking to me like I'm a web developer. It's hard, like it's not hard to learn the language, but you know, we are writing maybe TypeScript or JavaScript every day, going through C and memory management and maybe C++ or maybe writing Rust. It is awesome to learn these languages, but you know, for just doing some small task or maybe sometimes bigger task, maybe it's worth it, but it's not the way that I want to deal with this WebAssembly. Dealing with all of these new things from a new language, it takes time to get master these languages, right? So you need to learn these languages before you can actually use them for WebAssembly. But isn't it nice if you have a tool, let's say, that you can write the way that you're writing your application, maybe with TypeScript or JavaScript, and then use or leverage these techniques and hold off something from main thread to other thread? It is absolutely fine. And in fact, some other clever people before me thought about it, and they created something called assembly script. Assembly script is actually a compiler which has the strict set of assembly, all those strict set of types, and then you can actually write your TypeScript. It's very funny. I'll show you in a minute. You can write your TypeScript with those specific types, and it compiles it to WASM. So it's awesome. So it's exactly what we need. So let's have a look at how easy is that. In fact, it's pretty easy. So with few commands, you can simply just download assembly script via npm or whatever tools that you run, and you just initialize your project, and then boom, you have your TypeScript file, the main entry file. You can go and start writing your TypeScript. But the only difference is that you need to know those strict subset of types which are dedicated to assembly. You see it right now in this in the presentation. So once you know these types and you get familiar with that, the rest is just TypeScript. You just go and write your function. I wrote a function here, and I would simply using this assembly script, running one command, just as build, everything, boom, is there. You have your WASM file. And the nice part of that is when you are going to use WASM, if you have tried WASM initialization on the web, you know that it's a bit of work. You know, it's some steps that you need to follow, and then you get access to your object, your module. But then with WASM, with assembly script loader, it makes it so easy once you build your WASM, so you can just use this loader, and then it just emulsify your object gives you the service that you actually created. And you can use the functions that you exposed from TypeScript in assembly script. So here is an example here, so which I created. You see that I initialized actually is a WASM file, and then I assign it to some object. So I was using my object by calling the function, which was a promise, as I defined already in my assembly script, and then I could change the state from my file, from my application framework. So in fact, this is another way that to run maybe some task from main thread to assembly, WebAssembly. And the thing is that I'm going to show you actually a demo at the end, which I'm running a video decoder. I just record myself and decode everything to MP4 via FFmpeg, and it's all in JavaScript and nothing else, and it's WASM running in different threads. It doesn't block anything. And even if it blocks, I'm just spawning that into a WebWorker, and it just runs the animation smoothly as it should. Let's see that at the end of the talk. But before that, let me just emphasize one thing. Although when we are thinking about WebAssembly, the first thing that comes to our mind after those languages is that, wow, WebAssembly is fast. Well, it could be fast, or it could not be. But the thing is that you need to measure it. You need to measure what you are doing and see the result, whether it's faster or not, or whether it's more predictable. The good thing about WebAssembly is that when you are running these functions with WebAssembly, it runs in a line of performance and it stays almost in the same line. While in main thread, you don't have this. You have unpredictability. It could be very fast or sometimes slow, or, you know. So the reason that, another reason that you may want to spawn it to a WebAssembly running some business logic or some logic over there is that if the performance is, for instance, fast from the beginning, it will stay fast probably all the way around. But measure it always and test on different devices for sure, and different browsers. So, but that's not the only thing. So these days, browsers are giving us like even more options. And the third option for holding off some main thread task and to another worker thread maybe is worklets. This is a pretty new concept. They are around not many years and still don't have a good support in many browsers. But still, it's a very amazing things that we can do. And as I told you, when we are building a progressive web app, we can definitely check if a browser, it's a feature detect, right? If a browser supports these concepts or these APIs, and then we can give our user a better experience by using these APIs. Let me just introduce you to worklets. What are these? In fact, worklets are around just to give you an access to a low-level part of the rendering pipeline. This is amazing. Yes, that means you can actually render graphic, or you can process audio from a very low level, not just in main thread. And that is amazing. That is quite high performance, right? If we think about it. If you're asking me like how many types of worklet then we have when you are saying rendering then or processing, it's actually by now 4 types. We have Paint API, we have animation, layout, and we have audio. So each of them does differently. But for the purpose of this talk, I will talk about Paint API, which has better support these days. And at least we can maybe use it immediately in our application. Our CSS Paint API or some call it Houdini's paint worklet, or CSS custom paint, whatever you heard or you want to call it. So these are the names for CSS Paint API. Is a type of worklet, but what it does for you, it's amazing. It's just, you can just create your you can just define what you want to paint in your browser, and just write your JavaScript file and just try after you wrote that what you want to create. Like for this example, it's just a checkboard. You define your, you register your worklet JavaScript file, right? And once you registered, and as you see here, I'm actually checking if this paint worklet is already it already existed or not. And then once I have access to that, I can add register to this my worklet. And once it's registered, then you can actually call a paint function and actually paint something. And that doesn't block anything because it doesn't run in main thread. It just runs on somehow different worker thread, right? So let's see this example here. That is the exact example that you've just seen in the slides. You just create these boards. But what are the usage of that? Like creating these checkboards is like boring, right? So we don't want to do that. But there are better examples here. So imagine that you want to actually create like a barcode generator or something like that, like QR code, let's say. So you can definitely do that in main thread, write your application and manipulate and do that, right? But look at this animation here in this example. If you look at this as an example, you see that by manipulating these or painting or repainting this QR code, and I still have access to everything. I can change like very fast and nothing blocks. I'm just holding off this creation of this QR code to this thread or worklet, for instance. And that is amazing. So I have one demo. I hope it works. So let's give it a try. So what we are going to see right now, the demo is FFmpeg JS version, so which is like a compiled to WASM, and we're going to see this example here, and I see that it doesn't run. Okay, I see that it doesn't run my video. On the left side of this slide, you should see my video, and on the right side, you should see. You should not see anything, but I can start recording, which I cannot do it now. Yeah, I was expecting actually this issue. I have to open it in a browser tab and then refresh, and it works. So then let me explain how it works. You see the animation still is here. So I just open up my camera via media manager in the browser, see my camera, my face, right, like this, and I could start recording for a few seconds. And then once I record, I immediately stop. And then what it does, it just transforms these media from this camera to an MPEG-4 and then put it to this video player on the right side of the screen. And then you can even download the MP4. So all of this is happening in the browser. No backend, nothing. It's just browser, different thread. And to make it more smooth, because when you are loading these FFmpeg, it's a bit of time, and then it takes time to just do these, codec stuff to make it to convert it to MP4. But then it also once you're loading and initializing, it may have a little bit overhead on the main thread. So instead of doing that in main thread, then what we can do, we can hold off. That is amazing. You can actually put this whole initialization to a worker thread using comlink, get it just in proxy back, and then await from that, and then call this function and do all of this from actually worker thread. Once everything is done, get the result and show it to the main thread. And that animation will not stop at all. It just works smoothly while even you are decoding or encoding this video, or while even you are downloading. That is something that we wanted. I'm so sorry that I cannot show it here. The way that we set up actually right now presentation and the slide and things, I'm not able to open it in a new tab. I can, but I don't think if you can see it, because I can just share this screen for you. But later, you can come to this slide, go to this page and click and give it a try yourself. So it will ask you a permission. It will ask you for a permission, and then you have a permit. You need to give permission for video and audio, and then you have everything good to go. You can just give it a try. So let's move on. Let's have our final thoughts here. We've explored several with real, actually, examples, which I actually used it in my application. These are like examples, copy paste from application, and I just showed you here that it works perfectly. And they are all practical tips that you can use it right away, right? So let's embrace these power of workers, have it in the browser, different way of spawning these threads and just run different logics over there without blocking this UI, and make your application more reliable and usable. And with that said, I'm happy that I delivered this talk here for you, and I'll be actually online. You can, by the way, get the code and samples from this link, and perhaps they will post it for you. You can check it out later, and feel free to follow me. I'm usually active on Twitter, and send me an email if you have any questions for sure. I am ready to answer any question if we have.
Hi, Majid, can you hear me?
Yes, I can hear you clear and loud.
Cool. So we have some questions for you. So thanks, Majid, for the lecture. You shown the example with the UI animation. What do you think about using shaders, fragment shaders, for implementing this solution? As far as I know, they also can be implemented in your JavaScript code really simple and load your GPU instead of using CPU.
Yes. You definitely can do that. I haven't tried it, but so if you want like an example from my side, I don't have an example right now, but you definitely can try it. And by using some like techniques, you can actually hold off some of these let's say this animation, for instance, moving around. You can maybe hold off some of these tasks to GPU, as you said. So, but I bet that if you search on GitHub for such an example, you definitely find one. I don't have an example to give you like a link to go and check right now, but I bet you can find it on GitHub.
Okay, if you guys are writing questions, or there is one question from me. So actually, before we lived without these web workers and our apps were doing a bit just fine. So what will be the metric for your application that will indicate that you need to start using the web workers, or you can live without them in your current application?
Yes, as in the beginning of the talk, I actually showed you some phones, if you remember, and one of those phones was Nokia 2, right? And the price of that Nokia is, I think it's $20 maybe, or $30. It's very cheap. So if you think that your application is working very fine on a very powerful desktop with high internet speed and it works perfectly, then you need to go and give it a try and run your application on that device. and see if it works smoothly or not. So that is the time you feel that, oh, maybe I should think about it. You may think like, oh, well, maybe in my country, not many people use that. But, well, if you have a statistic, okay, go for it. But if you don't have a statistic, I bet that there are many are using even lower end spec of these devices, smartphone devices that you may even don't know. So measure. Also, when you are actually checking your application for testing, end-to-end testing, etc., running on like lower spec devices and see like if they are running smooth or not. And the best actually, which I do, it's manual testing. I manually test on these devices. I always have one very low-level phone that I run this application and check if my PWA or proxy web app, let's say, by pushing up all of these hard work to different threads runs smoothly or not, you know? So that is a good way to do that, perhaps.
Okay, great. We have some few questions. Not every case scenario deserves introducing more threads, correct? Some main points when we need to consider them. I think it's more or less the same that are asked, or a bit different.
Yes. Well, there are several actually use cases for threads. So the most important things, so I can give you like a list of use cases, right? Then you are limited to the list. I actually create like a pattern or a logic for myself, and I'm thinking when I have to put this to a worker thread and when not, right? So the way that I do it is that when it comes to a logic, what I do, I just check if this logic is blocking my thread and maybe delaying some other task. But you need to actually do some interaction while that logic is happening. Let's say in the example here, I had a list which I wanted to sort, and that wasn't a very big list, but it takes time. And that is the time when, you know, in the event loop, when you have a small event, well, it's fine. But when you have a bigger loop, then the whole event loop is blocked. So you need to just somehow hold off that bigger task to a worker thread. This is the way that you need to think. For instance, an example that unfortunately, I couldn't run it, but hopefully you will go and check it out, is that when you record a video, at the same time you stop and want to decode it to some other format, that's the time. So you should think like decoding, okay, the decoding takes maybe 1 minute. I cannot afford, my user cannot afford to wait for 1 minute to just decode and block everything. That is the time you should simply run in a different thread, right? Or maybe you are initializing one file, loading and doing some stuff, and it just blocks. Execution of JavaScript also blocks, you know, this UI. So maybe that is the time I need to do it actually in a worker thread, and once it's ready, I can put it back to a different thread. You're right. Just always opening up these threads and without cleaning up afterwards is also not a good idea. And so in one of the examples in the slides, I also had a terminate function on the worker thread. So once you know that you don't need this thread anymore, just do that. So do not just let them open forever. You know, it's good for a lot of stuff, especially for performance.
Cool. We have questions coming. So thanks for a valuable talk. Haven't heard about worklets and assembly script, a lot of new stuff. Probably it's too soon to speak about 120 Hz, enabling high refresh rate on the phone, increases battery drain to 10-15 depending on brand. The example was with sorting was probably run with some heavy CPU throttling or millions of iterations of some function call. So question, do you have some benchmarks, real-world examples, use cases of putting React on Redux to a WebWorker?
Yeah, well, I did it in my application. I show it for you here. in one of our applications, we actually put our reducers instead of main thread to the worker thread. That's a real example. That is exactly what I showed you right now in the slides. So that actually we've done it maybe a year ago. This example, we are quite satisfied because in some of our reducers function, let's say our logic, so could block the UI, and then we were thinking like, how can we just make it better? So we definitely need this synchronous, operation. We don't want to just make it asynchronous, right? But that's the way actually it works. Then we thought that okay, that's the time I can hold off this to a worker thread. So we did it, and that's a real example. And again, the examples that you saw here when I run sorting stuff, that's a real example. How many of you are sorting like a list in your application? You have a filter, you want to reorder, and do you do it actually in the main thread right now? But you can just simply hold it off if it blocks and if it's like a huge list, right?
Right.
Or how many of you like have a function, like a math function maybe, which is taking time, not a lot of time, but a time that can block even a small interaction, like a click on the button. And that's the time you can actually spawn a worker thread.
Cool. One more question. If a device has only 2 CPU cores and the app spawns 20 web workers, would that slow down the page too?
Yeah, well, that's the thing that a browser handles for you. First of all, even if you open a thread, 20 thread, that doesn't mean it will run, and it needs to run in 20 core. Cores and thread are two different things. You can spawn 20 thread and it runs in only one core of the CPU. That is something that browsers and in low level will handle it with your device. And of course, opening up too many threads with no reason for doing that, it's also not good. So it doesn't slow down your application, but browser may decide to like shut down this thread for you. So you may want to avoid it because browser try to like do all of this garbage collection and just free up the memory kind of stuff, right? So you don't want to actually mess with that. So when we are talking about thread, it's not about opening everything in thread. That's wrong. You need to run what is required, and it's blocking main thread to a different thread, right? That is the right type. And once you're done, you also need to clean up afterwards. I don't see an example of like opening up in one page 20 thread to do 20 different things. So perhaps you can modify it and have like maybe one thread, or 2, 3 thread, for instance, web workers.
Cool. Thanks a lot. I think we're done with the questions. Your talk was just amazing. I personally learned a lot of new stuff, and guys too. We have a lot of thanks also in our Discord chat. So cool. Thanks for a great talk again.
Thank you very much. Then have a good day and a good conference today.
Yeah,
see you. Bye.
Thank you, Majid. Bye bye.
Bye bye.